Okay, so now let's do the inverse of another matrix using elementary operations. So suppose that you have this matrix as, for example, A is equal to 0, 1, 2, 0, 1, 2, 1, 2, 3, 3, 1, 1, and you want to find the inverse of this matrix using row operations. Now, using row operations, you know that the row operations has to be done if you are multiplying some two matrices together. The row operations are done on the matrix on the right, right? So on the left, I'm sorry. And basically so if I write, instead of A, if I write I, and then if I write my A over here, and if I write my is equal to A, then I can do the row operations on the matrix on the right, and also do the row operations on this matrix. And if I do something, I mean, in these row operations, if I do a series of steps so that this becomes I, and this I becomes some other matrix, for example B, and this remains A, then this equation becomes basically B times A is equal to I, and that basically means that B is the inverse of A, right? So that's exactly what I will do. So I write A is equal to IA. So A is equal to IA would be basically 0, 0, 1, 2, 1, 2, 3, 3, 1, 1, and then I write it as I times A. So I would be basically this matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? And then I have the matrix A over here. Now I have to do as many row operations as required in order to get this matrix to look like exactly like this matrix. Now, if I apply R1, if I basically switch R1 and R2, meaning that if I apply R1 and R1 switching with R2, what I will get is that basically R2 becomes R1, R1 becomes R2. That means that I will write 1, 2, 3, 0, 1, 2, 3, 1, 1, and then I will write basically that the rows here have to be switched as well, meaning that 0, 1, 0, 0, 1, 0, 1, 0, 0, 0, 0, 1, and times A. Now if I apply basically R3 becomes R3 minus 3 times R1, if I apply basically R3 becomes R3 minus 3 times R1. So then basically row 3 becomes, you will get a 0 over here, because 3 minus 3 times 1 is going to be equal to 3 minus 3, which is equal to 0, meaning that you will get a 0 over here, some number over here, and some number over here, and as a result this becomes a 0, which is what we are actually looking for, right? So what I will do is that I will write basically row 1 and row 2 remain the same, meaning that I have 1, 2, 3, 0, 1, 2, and this row becomes basically 3 minus 3 times 1, which is equal to 3 minus 3, which is equal to 0, and 1 minus 3 times basically 2, which is equal to 1 minus 6, which is equal to negative 5, and 1 minus 3 times 3 is equal to 1 minus 9, which is equal to negative 8. So that is 0, negative 5, and negative 8. And you have to do the same thing over here, meaning that row 1 and row 2 remain the same, 0, 1, 0, 1, 0, 0, and then this becomes 0 minus 3 times 0, which is equal to 0 minus 0, which is equal to 0. And then you have 0 minus 3 times 1, which is equal to negative 3, and 1 minus 3 times 0, which is equal to 1. So this becomes 0, negative 3, 1. 0, negative 3, 1. And that multiplied by A. Next, what you need to do is apply R1 becomes R1 minus 2 times R1 minus 2 times R2. R1 minus 2 times R2. So that means that R1 changes here, and it becomes basically 1 minus 2 times 0, for example. 1 minus 2 times 0, which is equal to 1 minus 0, which is equal to 1. Or 2 minus 2 times 2, which is equal to 2 minus 2 times 1, which is equal to 2 minus 2, which is equal to 0. Or 3 minus 2 times 2, which is equal to 3 minus 4, which is equal to negative 1. So R1 here becomes 1, 0, negative 1. 1, 0, negative 1. 0, 1, 2, 0, negative 5, and negative 8. And the same thing I have to do over here, meaning that I will write basically 0 minus 2 times 1, which is equal to negative 2. 1 minus 2 times 0, which is equal to 1. And 0 minus 2 times 0 is equal to 0. So this 0 minus 2 times 0, which is equal to 0. So the row 1 over here becomes negative 2, 1 and 0. Then you have 1, 0, 0. Then you have 0, negative 3, and 1. And that times 8. So now we have basically 1, 0, negative 1, 0, 1, 2, 0, negative 5, and negative 8. So we have to take care of this element, we have to take care of this element, and we have to take care of these two elements. Now if I apply R3, R3 becomes R3 plus 5 times R2 plus 5 times R2, I will have basically so row 1 and row 2 remain the same, meaning that I will write 1, 0, negative 1, 0, 1, 2, and R3 over here becomes 0 plus 5 times R2, which is 0 here, which is equal to 0. And then you have negative 5 plus 5 times 1, which gives me a negative 5 plus 5, which is equal to 0. And negative 8 plus 5 times 2, which is equal to negative 8 plus 10, which is equal to 10 minus 8 is equal to 2. It means that R3 becomes 0, 0, 2. 0, 0, 2. It means that this now is taken care of. And of course I have to do the same thing over here, meaning that the first two rows are going to remain the same, meaning that you have -2, 1, 0 and 1, 0, 0, and here you have 0 plus 5 times R2, which is equal to 1, which is equal to 5. Then you have -3 plus 5 times 0, which is equal to -3, and 1 plus 5 times 0, which is equal to 1. So you have 5, -3, and 1 times 8. Next what I will do is that I will write this, I will apply R3. I will apply R3 becomes, let me do something to my pen. Okay, so the next thing that I will do is apply R3 gives basically 1/2 R3. 1/2 R3. So if I do that, so then I have the first two rows remain the same, 1, 1, 0, -1, and basically 0, 1, 2, and 0, 1, 2, and then you have 1/2 R3, half of 0 is 0, half of 0 is 0, half of 2 is 1. And again, I will do the same thing over here, -2, 1, 0, 1, 0, 0, half of 5 is 5 halves, half of -3 halves, and 1/2, and times 8. Then what I will do is I will apply basically R1 gives R1 plus R3. So R1 is equal to R1 plus R3 because I need to get rid of this -1. This has to become a 0. So -1 plus 0 becomes -1 plus 1 is equal to 0, right? So I will write this as, so R1 becomes 1 plus 0, which is equal to 1, 0 plus 0 is equal to 0, and -1 plus 1 is equal to 0. And the rest remains the same. And then you will have, again, R1 changes here, -2 plus 5 halves is the same thing as 2 halves, so -4 halves, that's -2 plus 5 halves is equal to 5 minus 1, 5 minus 4 is equal to 1, that's 1 halves. 1 plus -3 halves, so that is 1 minus 3 halves, which is the same thing as 2 halves minus 3 halves, which is equal to -1 halves. And then you have 0 minus that's addition, so 0 plus 1/2 is 1/2, so this last one becomes 1/2. So you have 1/2, -1/2, and 1/2, and then the rest remains the same, 0, 0, 5 halves, -3 halves, and 1 halves times 8. Next, what we will do is, so you have 1, 0, 0, 0, 1, 0. So the only thing that you need to change is take a 0 over here. Now to get a 0 over here, what you can do is basically apply R2. You need to apply R2 gives R2 minus 2 times R3. minus 2 times R3. So the first row remains the same, so 1, 0, 0. And R2 becomes basically 0 minus 2 times 0, for example, which is equal to 0. Then you have 1 minus 2 times 0. 1 minus 2 times 0, which is equal to 1 minus 0, which is equal to 1. And then you have basically 2 minus 2 times 1. 2 minus 2 times 1, which is equal to 2 minus 2 is equal to 0. So R2 here becomes 0, 1, 0. 0, 1, 0. And here you have 0, 0, 1. And that is equal to, again, you have to do the same thing here. The first row remains the same. 1 half, negative 1 half, and 1 half. R2 becomes basically, for example, 1 minus 2 times 5 halves, which is the same thing as 1 minus 5 is negative 4. And you have 0 minus 2 times 1 half, 2 times negative 1 half. So that is positive 1. And then you have R2, which is 0 minus 2. Excuse me. And then you have 0, which is basically R2, minus 2 times R3, minus 2 times, did I make a mistake here? I think I did make a mistake here. So over here I have R2 minus 2 times R3, so 1 minus 2 times 5 halves. Then you have 0 minus 2 times negative 3 halves. And then you have 0 minus 2 times 1 halves. So these two will be cancelled out. You have a positive 3 here, and then you have 2 and 2 cancelled out. You have a negative 1 here. So you have 4, negative 4, 3, negative 1. Negative 4, 3, negative 1. And then the third row remains the same. 5 halves, negative 3 halves, and 1 halves. And times A. I'm sorry. So I will erase all of this. And if I call this matrix, for example, B, so you can see that B times A is equal to I. That means that B is equal to A inverse, which means that basically the inverse of A, or A inverse, is equal to A inverse is equal to 1 half, negative 1 half, 1 half, negative 4, 3, negative 1, 5 halves, negative 3 halves, and 1 half. That is the inverse of A. Which is the correct answer. Okay. Now, we can actually solve the same problem using column operations. So now let's do the same thing using column operations. Now, if I have basically the matrix that I have is a 3 by 3 matrix. So I have A is equal to basically 0, 1, 2, 0, 1, 2, 1, 2, 3, and 3, 1, 1. And you want to find the inverse of you want to find the inverse of A using elementary column operations. So what we have here is, now using elementary column operations, when you're doing column operations, basically the column operation has to be, if you have, for example, two matrices A and B, the column operation has to be done on this matrix on the right. That means that instead of B, I will write some I, for example, and A times I, and that is equal to A, right? So I use this equation, do the column operation on A, do the column operation on I, and do the column operations in such a way that this A becomes I, and then this I becomes some other matrix, for example, call it B, and this remains A. I'm not going to touch this in any way, and therefore A times B becomes I, which means that basically then B is A inverse, right? So that's what I'm going to do, which means that I will write A is equal to A times I, and therefore I will write 0, 1, 2, 1, 2, and 3, 3, 1, 1 is equal to basically A times I, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. So now we can start with the column operations. So you have 0, 1, 2, 1, 2, 3, 3, 1, 1, and A times, oh, I have to move down here. Okay, so then what we can do here is that basically I can apply C1 to be swapped with C2, and therefore you will have column 1 swapped with column 2. You'll get 0, 1, 2. Actually you'll have to swap the column, so column 1 and column 2, so you write column 1 for column 2 first, so 1, 2, 1, and basically 0, 1, 3, 0, 1, 3, and then you have 2, 3, 1. So then that's equal to A times column 1 swapped with column 2, which means 0, 1, 0, 0, 1, 0, 1, 0, 0, 1, 0, 0, 0, 0, 1. And then you can apply column 3. You can apply column 3 becomes column 3 minus 2 times column 1, which means that column 1 and column 2 will not change, so I write 1, 2, 1, 0, 1, 3, and column 3 becomes column 3 minus 2 times column 1, meaning that you have, for example, 2 minus 2 times 1, and then you have 3 minus 2 times 2, and then you have 1 minus 1, 2 times 1, which is equal to 2 minus 2, which is equal to 0. 3 minus 4 is equal to negative 1, and then you have 1 minus 2, which is equal to negative 1. So you have 0, negative 1, negative 1. 0, negative 1, negative 1. And then you have A times, again, you have to you basically column 1 and 2 remain the same, so 0 1 0 1 0 0, and then here you have basically column 3 becomes column 3 minus 2 times column 1, meaning that 0 minus 2 times 0, which is equal to 0. 0 minus 2 times 1, which is equal to negative 2, and 1 minus 2 times 0, and that is equal to 1. So that becomes 0 negative 2, 0 negative 2 1, and that is basically this step. So now our goal here is that this matrix has to look like a identity matrix, meaning that you have 1 0 0 0 1 0 and then 0 0 1, meaning that these two have changed and these three also have changed. So we have a couple more steps to go, and then you can apply column 3 becomes column 3 plus column 2, which means that so column 1 and 2 remain the same, so you have 1 2 1 and 0 1 3, and column 3 plus column 2, so 0 plus 0 is 0, that's 0, and 3 minus 1 is equal to 2, and this is equal to 8 times, again, column 0 1 0 1 0 0, and column 3 plus column 2 would be 1 negative 2 and 1. Next, what you have is we will apply column 3. We will apply column 3 becomes 1/2 of column 3, right? So that means that column 1 and 2 remain the same, 1 2 1 0 1 3, and 1/2 of column 3 would be 0 0 and 1, and then you have 8 times 0 1 0 1 0 0 and 1/2 negative 1 and 1/2. And then what you will do is basically column 1. Of course, I'm just following the steps from the solution. I'm not doing much thinking here. So you have you can apply basically column 1 becomes column 1 minus 2 times column 2, right? So column 1 becomes, so for example, you have 1 minus 2 times 0, which is equal to 1 minus 0, which is equal to 1. And then you have 2 times, basically 2 minus 2 times 1, which is equal to 2 minus 2, which is equal to 0. And then 1 minus 2 times 3, which is equal to 1 minus 6, which is equal to negative 5. So the first column becomes 1 0 negative 5. 1 0 and negative 5. The two other columns remain the same, 0 0 1, and that is 8 times this matrix, which is, again, you have column 1 minus 2 times column 2, so 0 minus 2 times, for example, 1, which is equal to negative 2, 1 minus 2 times 0, which is equal to 1, and 0 minus 2 times 0, which is equal to 0. So you have negative 2, 1, and 0. Then you have 1, 0, 0, and 1 half, negative 1, 1 half. So that is this step, and then after that we need to apply basically column 1 becomes column 1 plus 5 times column 3. So so you have basically 1, for example, plus 5 times 0, then you have 0 plus 5 times 0, and then you have negative 5 plus 5 times 1, which is basically 1 plus 0, which is equal to 1, that is equal to 0 plus 0, which is equal to 0, and that is equal to negative 5 plus 5, which is equal to 0. So that's 1, 0, 0. 1, 0, 0. And then you have 0, 1, 3, and then you have 0, 0, 1. That is basically the first matrix, 8 times. The second matrix, you have a column 1 plus 3 plus 5 times column 3. So you have negative 2 plus 5 times 1 half, which is equal to negative 2 plus 5 halves, which is equal to, so basically 2 halves would be 1, so negative 4 halves, negative 2 plus 5 halves, so 5 minus 4 is equal to 1, that is 1 half, and then you have 1 plus 5 times negative 1, which is equal to 1 minus 5, which is equal to negative 4, and then you have 0 plus 5 times 1 half. 1 half is the same thing as 5 halves. So you have 1 half. So you have 1 half and negative 4 and 5 halves. 1, 0, 0. 1 half, negative 1, 1 half. And then you have 1, 0, 0, 0, 1, 0, and then the only thing that needs to be taken care of is this 3 over here. That has to become a 0. Which means that I will apply basically column 2 becomes column 2 minus 3 times column 3. And if I do that, so column 1 remains the same. That means that I have 1, 0, 0. Column 2 becomes column 2 minus 3 times column 3. So you have, for example, 0 minus 3 times 0, which is equal to 0 minus 0, which is equal to 0. Then you have 1 minus 2 times 0, which is equal to, well, 1 minus 0 is equal to 1, and then 3 minus 2 times 1 is equal to 3 minus I'm sorry, 3 times actually. This is also supposed to be 3 times. I'm sorry. So you have basically 1 minus 3 times 0, which is equal to 0, and then 3 minus 3 times 1, which is equal to 3 minus 3 is equal to 0. So you have 0, 0, 0. Actually, this is one, I don't know why I'm making a mistake. 0, 1, 0. 0, 1, 0. And then over here, you don't have any changes, so you write this as 0, 0, 1. And that is equal to 8 times Then column 1 remains the same, meaning that you have 1/2, -4, 5/2, and column 2 becomes basically 1 minus, for example, 1 minus 3 times 1/2, which is the same thing as 1 minus 3/2, which is 2/2 minus 3/2, which is equal to -1/2. Then you have 0 minus 3 times -1, which is equal to +3, and 0 minus 3 times 1/2 is equal to -3/2. And that is basically the second column. So -1/2 and 3 and -3/2. And the third column remains the same, 1/2, -1, and 1/2. And therefore, we have, if I call this matrix B, for example, and this is now I, so I is equal to A times B, which means that basically B is the inverse of A, which means that basically A inverse is equal to this matrix, which is 1/2, -1/2, 1/2, and -4, 3, -1, 5/2, -3/2, and 1/2. That is what we were looking for, and we got it. Okay, now we have another example here, which is not very, doesn't seem to be so lengthy. So we have P is equal to I times P. That is example number 25. Example number 25. So we want to find P inverse if it exists given that P is equal to basically a matrix, a 2 by 2 matrix as 10, -2, -5, and 1. So it seems that the solution that they have chosen is row operations. So in row operations you write your matrix as P is equal to I times P, because you want to do the row operations on the matrix on the left, and therefore I write basically 10, -2, -5, and 1, and I write it as I, which is basically 1001 times P, and do the row operations on this matrix. And if I apply R1 becomes 1/10 of R1, I will have basically 1/10 of R1 is 1, and -5/10 is equal to divide by 5 and -1/2. So I'm sorry, no, it's not actually related to that. So -2/10 is the same thing as -1/5, and then you have the same row over here, -5, 1, and that is equal to that. So the first row again here, you get 1/10 and 0, 0, and 1, and times P. Then what you will do is apply, so here you want to get basically a 0 here and a 0 here, right? So this is an example of a case where the inverse actually does not exist, and we will see how it actually happens. So if I apply, for example, if I apply R2 becomes R2 plus 5 times R1, R2 becomes R2 plus 5 times R1, then the first row remains the same, 1 negative 1/5, and R2 becomes, for example, 5 plus 5 times 1, which is equal to actually that's a negative 5, so that's negative 5 plus 5, which is equal to 0. And then 1 plus 5 times negative 1/5 is the same thing as 1 minus 1, which is equal to 0. So you get 2 zeros here. And that is basically equal to, then basically the first row remains the same, that is 1/10, and that is a 0. And this becomes again the same thing, meaning that R2, which is 0 here, for example, plus 5 times 1/10, which is the same thing as 5/10 is the same thing as 1/2. So you get a 1/2 over here. And also over here you will get basically R2, which is equal to 1 plus 5 times 0, which is equal to 1. And that is times P. So what that means is that now what happens is that now basically you can see that in the second row of this matrix you have 2 zeros here. In the second row, basically the whole row is zeros. And what that means is that you're multiplying P by some matrix. You're multiplying P by some matrix, and both of these are zeros. And this is not possible because, okay, so basically the sentence that has been written here under this exercise in the text is that we have all zeros in the second row of the left-hand side matrix of the above equation, therefore P inverse does not exist. Now I remember that we had this back when I was going to college, and well, for whatever reason we just accepted that, okay, so the inverse, if you have this type of situation, then the inverse does not exist, and I just simply didn't think about it. But that's not a very good approach. Sometimes you have to do that. Sometimes you have to look for the reason. And in this particular case, basically they're saying that the P inverse does not exist. First of all, if you do this multiplication, meaning that if you actually write P, the matrix P here, and multiply basically by this matrix, you will get exactly this matrix, right? So with the calculation there is no problem. Now the problem here is that I suppose, I'm not really sure about this, you might want to ask for a second opinion, or even if I happen to be able to find someone who happens to know about this, I will definitely ask, or I might ask. But I think that when you have this matrix, a matrix like this over here, what that means is that you can just simply write this as 1 negative 1/5. And that would be a row matrix. And what that means is that you have multiplied a 2 by 2 matrix. You have this basically 2 by 2 matrix, and you have multiplied that by another 2 by 2 matrix, meaning that you're supposed to actually get a another matrix which is 2 by 2, but this matrix is a 1 by 2 matrix, which makes no sense. And for the same reason, I think, I'm not sure, again, for the same reason, that means that the inverse does not exist, because this operation makes no sense. But of course, it would be different if, for example, if you had a matrix like this, for example, over here, meaning that, for example, if this matrix was a 3 by 2 matrix, and you got 2 zeros over here. If you got 2 zeros over here, you still have some elements over here that are non-zero. Even if in this row you got, for example, a 0 over here and a 1, that would still be a row, so you wouldn't have to worry about that. Or even if you got a 0 over here and you got a 3 over here, that would still be a row, you wouldn't have to worry about that. And then this row, since it comes between these two rows, then I suspect that there is no problem with that, and for example, this case would not mean that the inverse does not exist. But still, but again, we will keep looking for this case in the exercises, and hopefully over there we can come to a sound conclusion about this. So for now, I'm going to, based on what I see in the text, I'm going to see that since the second row of the matrix basically left hand side contains all zeros, therefore the inverse of P does not exist. And that is basically the end of this. Now, next what we have is a couple of exercises, not too many. Exercise 3.4. We will go through these exercises and hopefully we will come to a sound conclusion about this. I'll see you in the next video, and thank you.